Okay, so now we're going to be rolling into investigation two about similar figures. So, investigation one, we started to see what mathematically similar meant. We noticed that figures that were similar to each other had the same shape, but not necessarily the same size. So, one thing that stayed common when we enlarged or shrunk a shape is that the angles didn't change. But we did notice that the lengths of the sides change, resulting in a change often in perimeter and area of the shape. All right, so we're going to dig a little bit more into similar figures by actually creating some similar figures, or maybe not similar figures, by looking at some rules and doing some graphing on a coordinate plane. Okay, so here's what investigation two says similar figures. Zach and Marta want to design a computer game that involves several animated characters. They ask Marta's uncle Carlos, a programmer for a video game company, about computer animation. Carlos explains that the computer screen can be thought of as a grid made up of thousands of tiny points called pixels. To animate a figure, you need to enter the coordinates of key points on the figure. The computer uses these points to draw the figure in different positions. Sometimes the figures in a computer game need to change size. A computer can make a figure larger or smaller. You can give it a rule for finding key points on the new figure using key points from the original figure. All right, so we're going to do this by drawing some wumps. Okay, so two ones is drawing wumps, making similar figures. Zach and Marta's computer game involved a family called the Wumps. The members of the Wump family are various sizes, but they all have the same shape. That is, they are similar. Mug Wump is the game's main character. By enlarging or reducing Mug, a player can transform him into other Wump family members. Zach and Marta experiment with drawing and reducing figures on a coordinate grid. First, Zach draws mugwump on graph paper. Then he labels the key points from A to X and lists the coordinates for each point. Marta writes the rules that will change mug's size. Okay, so Marta tries several rules for transforming Mug into different sizes. At first glance, all the new characters look like Mug. They look like they might be mathematically similar to Mug. Some of the new characters are quite different, however, they are not mathematically similar to Mug. Okay, so what we're going to do is we're going to create Mug and some of the other game characters by applying some of these rules. Okay, so let me show you what this drawing is going to look like. So you're going to now open your orange folder to page 3. Okay, and we're going to look at drawing some of our characters. So remember what he said about that they had kind of key endpoints to make their game character. Well, the key endpoints for Mug are kind of, and this is like the little rule here. So what you're going to do is you're going to take Mug Womp, okay, and take these points and you're going to graph him on the next page. Okay, now if you're having a hard time of going back and forth, you could take these pages out of the back if you want, okay? And that might make things a little bit easier, okay? So, but basically you're going to be taking these and then graphing them on the next page. Okay, so I'm going to do kind of two copies next to each other so I can see them and don't have to flip back and forth. Okay, and same thing for you. You might want to just take them out, but be sure to put them back in. Okay. All right, so I'm going to first try and make Mug, okay, on the paper on the next page. Okay. So it says Mug is drawn by placing these different points on the grid. Okay. So point A is at 0, 1. Okay, so this is X and this is Y. So I'm going to go X 0. Okay, so I'm going to move over all and then Y 1. And I'm going to put a dot there. And then I'm going to go to 2, 1. So I'm going to go to X 2 over to 1, put a dot here. Okay. And then I'm going to go to 2, 0. Okay, then 3, 0, kind of, etc. Okay, I'm going to do a little pause here. All right, so did you get those points plotted? Okay, so then you're going to go ahead and just connect them. Like a dot to dot. Okay, and then first part basically made Wump's body. Okay, so now I'm going to start over and I'm going to plot these points. Okay, so 2, 2, 6, 2, 6, 3, 2, 3, and then back to 2, 2. So that's going to make his mouth. Okay, so I plotted these points, and now I'm going to plot these and connect those. So let's see, 3, 4. So 1, 2, 3, 1, 2, 3, 4. Yeah, shoot, 3, 4, 4, 5. Shouldn't have put that out there. Okay, and then let's see, 5, 4, and 3, 4. And back. Okay, so that makes his nose. All right, so then I'm going to plot the last 2 points, which are 2, 5, and 6, 5. So I'm going to go over 2 and up 5 and plot a dot, and then 6, 5. Okay, and there we have Mug. Okay, so then what you're going to do is you're going to make the 4 other characters using these rules, and you're going to plot these on this page. Okay, let me show you how you're going to make the rules. Okay, so Zug says rule 2x 2y. So you're going to take Mug and you're going to take each x value and double it, and each y value and double it. So like 0 times 2 would be 0, 1 times 2 would be 2. So I'm just multiplying both of these things by 2. So I've got 4, 2, so this would be 4, 0. Okay, so multiply that by 2, so I'm going to get 6, 0. Multiply each of these by 2, kind of, etc. So just doubling each one. And doubling each one. So multiply each of those by 2. Okay, and then I'm going to do the same thing for these. Multiply each of those by 2. By 2. And then same with these, double each of these. Okay, and then the dots for the eyes. Okay, and so then after you have those coordinates, you're going to go ahead and plot them on here for Zug. Okay, and then here's how you're going to create lug. This rule says 3 times x, leave y alone. So I'm going to take my x and I'm going to multiply that by 3. So 0 times 3 is 0, and leave y alone. Okay, multiply x by 3, leave y alone, x by 3, okay, etc. So then just go ahead and fill out that row by tripling x, and then leaving y alone. Then for Bug, you're going to triple x and triple y. So I'm going to do 0, 3. Okay, so multiply that by 3. So I'm going to say 6, 3, 6, 0, 9, 0. So I'm just tripling as I go down here, both the x and the y. And then to create glug, you're going to leave x alone, but you're going to triple y. So 0, 3, x alone, triple y, leave x alone, and triple y. Sorry, goodness. Leave x alone, sorry, leave it alone, 2, this should be a 2. Leave x alone, triple y, leave x alone, triple y. Okay, and then fill out that whole row. Okay, so X alone, triple Y. Okay, once you've got that table filled out, you're going to go ahead and you're going to graph them over here on the next page. Okay, go for it. Okay, so how'd it go? Here's what the data should have looked like when you filled out the rules. You should have a mug looking graphed like that. And then the other Wump family, here's how Zug, Lug, Bug, and Glug should have looked. All right, so then there's a few questions I want you to think about on page 8. So it says, compare the characters to Mug, which are the imposters, not members of the Wump family. Think about what things are the same about Mug and the others, and what things are different about the 5 characters. So go ahead and just try and answer those. All right, so let's think about the imposters. So here's Mug and Bug, Lug, Glug, and Zug. Okay, so which ones are actually members of his family? And if you remember from earlier in the book, the members of the family are they either enlarged or shrunk Mug. Okay, but didn't distort him. Okay, so they were actually copies. So did you think that Zug and Bug were the ones that were part of the family? Okay, and Glug and Lug were not. So if we take a look at this, notice something about the angles of Bug and Zug. If I put Mug on here, do you see how his angles, like at the angle of his head, is the same as Bug? And same with Mug and Zug. So the angles end up being the same, don't they? But if I compare Mug to Glug, I can check out these angles to see how the angle on his head is not the same, or the angle down, like kind of on the side of him, is not the same. Okay, so the angles definitely changed, okay, when we looked at the imposters, okay? So the angles should have stayed the same for these guys, and the angles changed for the 2 imposters.